Hello and welcome to Waka Waka Breaking It Down for our continuation of inverse functions. Today's focus is going to be on like composite functions with inverses, what those look like, and also word problems. So this is the worksheet we're going to be going through. Let me pause this. I gotta cancel this. Quit that. Okay. All right. So this is the worksheet we're going to be using. It's got Sweet Yo's frozen yogurt on it, and the premise is that the school jazz band is going to go there for a party or something, for an event. They're going to charge $5 to get into the event, and then when you're there, you can eat froyo frozen yogurt, and they're going to charge you 40 cents per ounce for each cup of yogurt or whatever, for how much yogurt you get. So they give us an original function. It's always good to kind of make sense of that in your brain first before you get too deep. So what's the $5 mean? Well, that's how much it cost me to get in. What's this 0.4 times x? Well, x is the ounces of frozen yogurt you're going to be getting. And then it costs you 40 cents per ounce. So that's why those are multiplied together. What is f of x? Well, that's the amount of money you're going to spend overall, right? So when we get into it here, they ask what's the input? Well, the input is the x, and they tell you it's the ounces of frozen yogurt you're going to be getting. What's the output? That's the part B here. The output is f of x. Well, that's how much money it's going to cost you to go to this event and eat frozen yogurt. So $5 to get in, plus how much money you spend on yogurt. So that together will give you the total cost in dollars. All right, part C. They say they're going to restrict the number of ounces you can get to 24 ounces. Maybe they're going to run out, or that's just how much their cups will hold, or something like that. I don't really know. We don't really care. But they say, what's the minimum amount of money you would spend or that you need to bring with you if you go to this event? Well, one way to look at it is just saying, well, I'm not going to get any frozen yogurt. That's going to be the cheapest thing. So we're going to do f of 0. So if I put 0 into there, it's still going to cost me $5 to get into the event, right? So the minimum is going to be $5. Now they also say, what's the maximum? Well, they said we want to maximize 24 ounces is the most frozen yogurt you can get. So you can put that into your equation, right? It's going to be 24 times your 40 cents. And then you also add $5 onto that. And when you do all that, you'll get $14.60. Okay? So it's just plug and chug there a little bit, right? And thinking a little bit, minimum, maximum. They put some restrictions on there, which you have to pay attention to. But keep in mind what's the dollars and what is the ounces of frozen yogurt. So you just have to kind of keep those in mind. Units really important, right? The units are really important. Now it says graph that. So here's our graph. This wasn't given to you. You have to graph it yourself. This is the y-intercept, $5. That's how much you pay to get into the event. So if you don't get any frozen yogurt at all, you still pay $5 to get in. And then we're going to have a slope of 40 cents. So for every ounce, I'm going to pay another 40 cents. Now, the trouble with graphing that is it's hard to go up just 1 ounce, or sorry, just to go over 1 ounce and then go up 40 cents. That's really difficult. So it might be easier to use chunks of 5 ounces instead of just 1 ounce at a time. So let's say I got 5 ounces of yogurt. Just the yogurt itself would be 40 cents times 5, which is $2. So it's easier to say, let's go over 5 ounces and then go up $2. Over 5 ounces, up $2, et cetera, right? And then that will be your graph. They ask for the domain and range. So when I look at this, now remember they said the maximum you can get is 24 ounces. So you can get no yogurt, which is 0, and you can go all the way up to 24 ounces, which is your maximum. So that's your domain. Notice how they're equal to. So it's less than or equal to, less than or equal to, because you can have 0, right? And you can have 24. It doesn't have to be less than that or anything, or in between that. Okay, range. Well, remember $5 to get in, and then the maximum I paid was $14.60. So if I maximize my frozen yogurt, I'll be up here at $14.60, which is the maximum. All right, so my range goes from 5 to 14.6. Notice how they're using f of x. That's kind of the dollars, right? That's was your output. That's the amount of money. And that goes along with the 5 and the 14.6. You could put y here, and that would be okay. That would be acceptable. But f of x is just a little nicer. Just a little nicer. All right, now we get into the inverse of that function we were talking about there. So we need to find the equation of the inverse. So how do we do that? Well, we take the original equation, this one up here, right? This guy. We're going to switch the x and the y. So the x goes over to the left, the y goes over next to the 40 cents. And that's what we end up with here on the top. Okay, I haven't solved yet though. So next step, I subtract the 5 from both sides. You can see the 5's been moved over to the left. And then I still have the 0.4 to deal with, so I have to divide by 0.4 on both sides to get y by itself. So there's your equation. This is your inverse equation. And we just flip it around a little bit, put it on the right-hand side, and then we change the y into inverse notation to kind of let the reader know this isn't just a regular equation, right? It is an inverse of something else that I started with. And that notation really shows us that, and that's why we use it. All right, so what's the input of this now? Well, now it's all backwards. So the input is the dollars. That's the total cost. And then the output is your ounces of frozen yogurt. So we're inputting dollars and outputting frozen yogurt ounces, okay? So it's all backwards now. You can see on the graph, we're going to do that next, but you can see on the graph here that here we inputted ounces and we outputted the total cost. When you do the inverse, you're inputting the cost and you're outputting ounces. So the units have switched, the x and the y have switched on us, okay? Oh, different now. All right, so that's what they say, graph the function. You can do the same thing we did before and kind of think about slope and stuff, but to be honest, it's almost easier to look at your original graph and just plot these points backwards. 0, 5 will graph to 5, 0. 5, 7 will plot to 7, 5, right? Etc., etc. 10, 9, you flip the x and the y and you get 9, 10. So you're just flipping the x and the y and plotting it out. Another way to look at this is if I had my original graph and I made the y equals x line. Sorry, a little crooked there, but if that was the y equals x line, the inverse is a reflection over that line. So this point goes over here. This point goes over here. Like this is 5, 7, so I go 7, 5. That goes over here. This point somewhere over here stays the same. And then this point goes up here, and this point goes up here, right? So you end up with a graph that looks something like this, up to 24, right? Well, let me move that down. This is the beauty of me writing on here. Do you see how that, oops, I was a little off, but that's kind of the right idea, right? It's just a reflection over that y equals x line. And I think they actually have a picture on the next page. Look at that. So we take our original, this red one, reflect it over the y equals x line, and you'll see how you get the blue line. All right. So that's our inverse function graphed out. They also ask for the domain and range of that. What you're going to notice here, and that's kind of one of the points of this, is when you do an inverse, the domain and the range, like this is the range. Look at the range of the original. And then that becomes the domain of my inverse. And the domain of my original becomes the range of my inverse. You can obviously see it from the graph, right? The domain goes from 5 to 14.6, and the range now goes from 0 up to 24. That's completely just the opposite of what we had before, right? The opposite domain and range. Ah, I see. So hopefully you're making that connection. Domain and range, x and y's are all switching, right? All right, so this is just a different way of looking at it. They ask us to do what I just already talked about, right? You're doing a reflection of the y equals x line. X's and y's are switching, and that's why the domain and the range switch as well. All right, let's go to number 4. So new event. Oh, no, sorry, same event. We're still talking about frozen yogurt. Ross comes to the event, and he spends $9.40. Okay, so how much yogurt did he get? Okay, so you have a choice of equations. We have the original equation and we have the inverse equation. You could technically use either one. I could use the original and then just replace this with 940, right? And then just solve for x. But we already have this inverse where I solved for x already. This has already been solved for the ounces of frozen yogurt. So I can take this equation and just put 940 in for x in this equation, and you'll get the same thing out of it. So 940 minus the 5, and then you have to divide by 0.4, and you'll see that you can see that that's what they did here, and we get 11 ounces out of that. Don't forget the units, right? Always think it through. 940 is dollars. That means the 11 is in ounces of yogurt. Okay? So inverse, like if you have dollars, then you probably want to use the inverse equation, but you don't have to. That's what we want you to do though, like just so you can practice using inverse functions. Okay, now we got Sophia. She bought 10 ounces of frozen yogurt. So how much did she spend, right? So now we're using the original equation. Put $10, 10 ounces in for X, and you can solve and get $9 is what she spent. $5 for the entry fee plus $4 for the frozen yogurt. Mike spent $9. Okay, now we're back to the inverse again, right? And we're just going back and forth, back and forth. So if he spent $9, that means he bought 10 ounces. You just plug it in. All right, now this is something new. We're doing the inverse of the original function. That's what this is asking you to do. And it's just a little trick, really. It's just trying to get you to see what's going on in the relationship. Think about what an inverse and a function are. If you, like a function takes a value, like in this case 10, and it's going to go forward with that. Sorry, I'm jumping around a little. So it's going to take this original equation and put 10 in there. So that's 40 cents times 10. That's going to be $4. My $4 plus $5 is $9, right? So you'll see, whoops, went too far. So you see they got $9 for just this inside piece. So that gets replaced by $9. But now they're going to go backwards and put $9 into my into my inverse equation, which they actually did that on the previous question, right? But just to remind you, we're using the inverse equation now, the one that I found back here. So we're putting $9 into that equation, which looks just like this up above here, and you get 10 out of it. Now, wait a minute, 10, isn't that what I started with? Well, yeah, it is. That's the whole point of this. The whole point of this is that inverses of functions, right, like it's written here, it's kind of like going forwards and then going right back, like going forwards and then going backwards, right back to where you started. So no matter what you started with, it doesn't matter where you went because you're going to go right back to where you started in the first place. So 10 will map to 10. It just goes back to where it started, right? You could do this backwards as well. It's the same thing. Even if I put the inverse first and did the inverse of 10 to begin with, right? This is still going to equal 10 because, it doesn't matter where I started. If I start at the end and I go backwards and then I go forwards, I'm going to go right back to where I was. So it doesn't matter. Like a function of an inverse or an inverse of a function are always going to take you right back to where you started. So in this case, now we're going to do the work, but I wouldn't even have to do the work. I can look at that and I know that this is going to simplify back down to x. Now, that's only true though if these really are inverses of each other. If this function is an inverse of the other function, if they really are inverses. If they are, this should take me right back to where I started, which is x. All right, so this is one main topic of this particular lesson. All right, so how do we work with this? Well, it's kind of funky, but we're taking that original equation, right? F of x is equal to 5 plus 0.4x. So we're taking that whole that whole expression and plugging it in to the inverse function. Remember what the inverse function looked like. So this whole piece here is this whole piece, and that gets put into the inverse function where x was. Maybe I should point that out to you. So on the inverse function, this is where x is. That little spot is going to contain the whole original equation. Oh, my thing froze on me. I hate it when it does that. Okay, I'm jumping around now. Okay, is going to contain this whole equation inside of it. Okay, so that's why this looks the way it looks right here. Okay, and then it's our job to simplify that down. 5 and minus 5 will cancel. That leaves us with this. Oh, this is a typo. This is supposed to be, let me change this while I'm standing here. That's supposed to be 0.4. So 0.4 divided by 0.4 will cancel, right? These will cancel. And I'm just going to have x left over. Shazam, right? We go right back to where we started. You could do it the opposite way as well, right? Which is what they're doing on part B. So part B is taking the inverse equation, which is all of this, right? Taking the inverse equation and sticking it inside my original function. So here's my original function, right? So they're putting that inside where the x was on the original function. Then it's our job to simplify. So 0.4 divided by 0.4 cancel, and I'm left with this. 5 minus 5 will cancel, and I'm right back to where I started with x. I mean, it's no surprise, right? Like you kind of did something to a number, and then you undid or like you went backwards or undid the same things, but backwards, right? So of course you're gonna like, if you multiply by 5 and then you divide by 5, you're gonna go right back to where you started, right? That's really all it is. All right, number 9, comparing your answers. What do you notice? Well, we notice all the stuff I just said. It's always going to be equal to x, and that's always going to be true if those two things are really inverse functions of each other. Okay, so if you see something like this, you don't have to do any work. It's always going to equal 5. So on a test, don't waste your time. Just write 5. You're done. You don't even have to do this. But you could, but you don't have to. You just can write 5, done. They are inverses of each other, so you're going to go right back to where you started. Okay, that's really the lesson, but then here we have some more problems as some extra things that you can use to practice. I'll quickly peruse through this, all right? So we got someone who won $100, and then they're going to sell plants for $15 each. You can read, pause it and read through it. She only has 10 plants though, so like the maximum she can have is 10 plants. So here's our equation. $100 is the just a one-time win, and then $15 per plant, but I can only go up to 10 plants. All right, we do the inverse, so we flip it around, solve for y, so subtract 100 from both sides, and then divide by 15, and you get your inverse. Notice we're using inverse notation. All right, now this part, I'm going to actually kind of slow down for this a little bit, but they want you to check to see if these really are functions of each other, like if you did it correctly, by using this method. And you will be asked to do this on a test. So what you have to do is take one of those functions, like in this case, let's take this is supposed to be like another parentheses or whatever. All right, so we're going to take the inverse and we're going to stick it inside the original. So here's our inverse that we had, and we're sticking it inside the original equation, and then we're simplifying. 15 cancels, and then 100 minus 100 cancels, and you're right back to where you started. If you get x out of this, right, if it comes back and says equals x, then that's proof to you that what you did was correct, that the inverse you found really is the inverse of the original, like you did it the right way. And you don't have to do it that way. You can do it the reverse way as well. It doesn't matter. You don't have to do both. You just pick one and do it. Right? Another quadratic situation, just another function situation. This is just more practice with domain and talking about inverses, right? The one thing about this is that we're going to restrict the domain on part of this to make it into a function, right? So this red equation here, which is this quadratic, we already know that's a function by itself, right? But, and you can practice the domain and range. But if I do the inverse of that in blue, we know that that's not a function. Now you can also do the domain and range of that. Their question is, well, how can I restrict the domain of the original? So how can I cut this domain of the original so that when I flip it over, the inverse is also a function? And what we're just trying to get you to do is just take a piece of this, like maybe just take this chunk of it, and then when you do the inverse of it, it'll only be this piece only, and then you'll know that you do have an inverse function. But that's only if you take the first part, right? So they're saying, well, let's just take x is greater than 1, just this piece, and we can use that to make an inverse function, an inverse that is a function or does have an, or is a function. Okay, and then it's just some function notation, right? Just practicing that a little bit, solving a little bit, right? These are things you can do. All right, that's the end of the video. Ask questions as always. Check the unit plan. There's always extra videos from other sources and other practice worksheets in there as well. And good luck studying.